안녕하세요. My name is Russ Scammell. I'm the technical product manager for 2D at Unity Technologies. And today, I would like to give you an update about 2D features in Unity. I want to talk about what we've released with 5.6, what is coming soon, and what is in development. So I'd like to know about the audience in front of me. How many of you are 2D game developers? 2D game developers. Okay. How many of you are shy 2D game developers? You don't want to put up your hand? Okay, never mind. So we've actually been releasing a lot of new features with 2D in 5.6. Today, I'd like to review some of those with you, and then we're going to learn what they are, how they can be set up, where they are in the editor, because they are in different parts of the editor, and what workflows they address. Okay, so we have a lot to cover, so let's begin. So the first thing I want to talk about is what we've released. So we've released a lot of new features, and I'm going to start with 9-slice. So this is a technique that we use to split and reuse different portions of an image. This allows you to prepare this kind of thing without having to prepare multiple assets. It involves splitting the image up into different portions. And we're going to see that in action. I'm going to show you in Unity where do you do this, and then how can it be applied to your renderer. So there's no need to prepare these multiple assets, and it's really useful when you're creating repeating patterns. For example, you want to tile a wall or a floor. So the example that we're going to see in Unity is a platformer. Okay. So let's open up the 9-slice example. Okay. And here's a scene where we have a platformer. We have Unity-chan, and she's trying to get around on this platformer. And we want to find a simple way to lay out this level easily. So what we've got here is sprite renderers that are using a 9-slice. So what is that exactly? So let me zoom in here first on the 9-slice sprite. And then let's take a look at the sprite editor. Actually, I can zoom out a little bit. Is that okay? Can you read that? Okay. So in the in the sprite editor, we define a 9-slice like this, right? You can see it's cut into 9 areas. And when we use this with a sprite renderer, certain parts of it will be tiled. For example, the middle will be tiled. The sides will be tiled along one axis, and then the corners will not be tiled at all. And you define them by defining the border values of left, top, right, and bottom here. Okay? So I'm not going to make any changes here. We can just take this outright. And let's take a look at one of these sprite renderers in the scene, one of these game objects. So this one has, if we look at the sprite renderer component here, I'm going to zoom in on that. We can see that it's using that 9-slice asset, and it has a draw mode of tiled, and that's how you get this to work. Now, there's different ways that we can do 9-slicing. In this case, we're using a tile mode called continuous. So if we look at the continuous mode, if I resize this, you can see that the center is getting tiled, but then sometimes you're going to come across a halfway mark, right? And you'll see the tiling, it's very obvious. There's no stretching. It's just repeating the pattern in the center, and then the sides are being tiled along the X or Y axes, right? So let's say that you wanted to complete the tiling in the middle. Let's look at this one. So for this, we're using the same tile draw mode, but for the tile mode here, we've got adaptive, right? Adaptive. So what does that do? So pay close attention to the middle sections and the sides. Okay, let's look very closely at that. Let's see what happens when I resize this. You see we stretch the sides, and then when it becomes too small or too big, we add an extra tile. So this is a really useful technique for creating these kind of repeated patterns, right? Cool. So that's 9-slice. What else have we released? Okay, to go back into PowerPoint, let's take a look at the edit outline mode. So when you bring a sprite into Unity, we generate a mesh. And what the edit outline mode allows you to do is to refine that mesh. So you can change what that mesh looks like for the sprite after it's been generated. And you access this via the sprite editor window. So we're going to go back into Unity and see that in action. Okay. So first of all, let's look at this scene. We've got a scene with a bunch of zombie heads in it. Okay, there we go. Zombie heads. And I want you to look at the overdraw. Oh, it's not quite noticeable here. So what we've got, I'll show you in the shaded wireframe mode. So we can see how the different meshes for the sprites are overlapping. And whenever we get these overlaps, you get an overdraw, right? And that's just unnecessary rendering, right, for those pixels. What we want to do is refine the shape around the head so that it's a tighter fit. So I'll show you a few ways that you can do that. So first of all, let's go to the sprite, and then we'll open the sprite editor. And I'm going to do this in alpha mode so that you can see the outline more clearly. What you want to do is change this mode up here from sprite editor to edit outline. And if I go into the alpha mode, you can see there's an outline for this, right? Now there's a few ways we can change this. At the moment, it's been automatically generated, so let's stick with that. We can change the outline tolerance, this slider here. So if I change this higher, and I hit update, I get a tighter fit of the mesh, right? And if I hit apply now, and we go back to the scene, you can see all of the meshes have been tightened up. And if you look at the overlap, it's almost non-existent. There's no overlapping transparent pixels, and that's a good thing. So you often want to use the sprite editor to find the balance, right, between polygon count and alpha overdraw. Let me show you a little bit more about how you can edit the outline. So let's say this is too tight, right, that we've got too many polygons here. We think we can do a better job by custom editing. So we're going to turn outline tolerance back down, hit update, and then what I'm going to do is I'm just going to come in here and I'm going to click on any of these edges to add a vertex, and we can do custom editing of these vertexes. All right, there we go. And that's exactly how I want it to be. Great. Hit apply. And now I get the same effect that I wanted just now, but with fewer polygons, right? Because I customized it. Great. So this gives you a lot of power over the trade-off between polygon count, as I said earlier, and alpha overdraw. So that's the edit outline mode in the sprite editor window. Okay, we've done a lot of work in Unity 5.6 to improve sorting. So sorting in 2D it's a fundamental thing. You know, you often want to make sure that the order in which your sprites are drawn, you have some control over that. You want to make sure that maybe you want your sprites to the ones that are further up to be drawn further back, the ones at the bottom to be drawn forward. So I'm going to talk about two different ways that we have given you control over sorting. The first one is the sorting group component. So in this, we're going to use our zombie again. This time he has the rest of his body. And we are going to try to solve this problem. right? So these two zombies, their drawing is being mixed up, right? This is not good. What we want is this, okay? So this is very common. This is a very common thing that you want to do when you're making 2D games. You make a hierarchy of game objects because you want to animate the limbs, as we saw in the earlier presentation. But maybe you also want to make sure that the hierarchies draw in a group, okay? So let's take a look at it in Unity. Okay, so we're still in Unity 5.6. Now we are looking at the sorting groups. Okay, so let's see the actual problem. If we go to our, okay, let's turn off the wireframe, we don't need that. And let's take a look at these two zombies. If I select this one, and I try to move him in front of the other one, it looks like he's giving him a hug, and then it all goes wrong, right? So that's all getting mixed up, and that's terrible. What we want is for the first zombie, this one, to be drawn in front, and then the other zombie to be drawn behind. Now the problem is they are made up of a very deep hierarchy with a lot of different parts, and there are many different sorting groups, sorting layers, and order in layer. So how do we do this? Let's look at the example that solves this problem. If we go to with sorting groups, okay, we have the same zombies, but now if we zoom in on the hierarchy, we can see that at the root level, they each have a sorting group, right? So the sorting group will give you control over the order in which we render the sprite renderers. Okay, so if you take a look here, this one has a sorting layer of default and an ordering layer of 0. And this one has sorting layer of default, ordering layer 1. So we immediately know which group is going to be drawn first. And without doing any other work, we haven't changed anything else to the internals of these zombies. I can just move this one, and the entire zombie draws perfectly in front of the other one, right? The entire hierarchy has been grouped. Okay. What we want to see now is a common use case in video games. If you are doing a 2D game and you have characters that are walking in front of each other, or you have rows of houses, or you have a level, very often the sprites that are at the top, you want them to render behind, and the sprites that are at the bottom, you want to render in front. This gives you that kind of perception that you're looking at it from an angle, but you also want the sprites to be upright. So what we really want to do here is we want to take control over the rendering order based on an axis. Okay? So renderers in Unity are sorted by several criteria, such as order in layer or distance from camera. What we've got here is the axis distance sort, which adds the ability to order renderers by distance along an arbitrary axis. Right? So we do this by extending the transparency sort mode. Okay, so this is the use case. You have a lot of zombies. You want the ones above to be rendered at the back, the ones below to be rendered in the front. So let's take a look at how we do that in Unity. Okay. So here's the axis distance sort. Okay. Now you can already see this is wrong. We want the one at the bottom to be rendered in front. So let's take a look. We want this one to be rendered in front when he's down here, and then if he goes behind, we want him to be rendered behind. So this is correct, but this is wrong. Right? Okay. So what do we do? So as you can see, we just changed, it just flipped again. So you have no control, right? And we want this level of control. Now he's in front. This is not good. So how do we do this? We go to Edit, And we're going to go to Project Settings, Graphics. And what we want to change is this. Okay, what we're trying to change is the transparency sort mode and the transparency sort axis. So what we can do here is we can change this to a custom axis. What we want is the vertical axis on the screen. And what do we want this one to be? The sort axis should be 0, 1, 0, right? So that's on the y-axis. Okay, so that's all I've done. Change that. Let's take a look. Now, when he walks in front, he's good. And when he walks behind, he goes behind. So we've controlled rendering order based on the axis, right? So then you can do, if you want, you can even get one zombie to orbit another zombie, right? No problem. That actually looks correct. Great. All right. Now, we've also made a lot of changes to the physics. We've added a lot of really good stuff to 2D physics. I'm not going to demo everything. I will show you a couple of examples, but we've made a very nice addition called the Contacts API. So this allows you to get information on how two colliders are interacting. For example, you might want to know where their interaction points are, and maybe information about their speed, things like that, at the point of interaction. We've added a composite collider 2D. This allows you to combine two colliders together. So I'll show you a use case for that. And we're also going to look at the edge radius feature, which allows you to increase the radius of collision for an object, as well as create rounded corners. You can also get the distance between two colliders. This is a very common thing that you want to do in games. You want to get the distance between two things, so that is now a feature. And all of the particle collision code in 2D, so when you're colliding particles in 2D now, that's been rewritten in SimD, so there's a very nice performance boost that you get on that. Okay, so let's take a look at some of these examples in physics. Okay, first thing we want to look at is composite collider. Okay, so let me open up Unity 5.6 again. Let's take a look at composite collider. Let me just close these up. So don't save. Okay, so imagine you have a scene like this, right? Maybe you're making some kind of a platformer game, and there's some physics elements to it. And typically, each of these boxes up here is separate, and we have a box collider 2D on each of them, as you can see. If I hit play, this is the expected behavior, right? Everything just falls apart. Now, what if I wanted to simulate all of these boxes as a single group, right? So let's imagine that all the crates are stuck together. How do we do this? So previously, you could try to draw out the outline, right? Or we can look at this example where we've got all of these boxes have been merged into a single collider. You can see that the green lines that represent the collider are actually just a single mesh now. But how have we done it? That's the interesting part. So at the very root, we have a composite collider 2D, right? So if we look at that, you can see composite collider 2D, that's the new component. And it is collecting all of this data from the colliders that are children, right? So here we have box collider 2D, right, on one of the children. And you can see the checkbox used by composite has been checked. So what that means is, instead of having all of this information, right, we are just giving the box collider 2D data to the composite collider 2D. And that is consuming all of that. Now, why is this a good thing? Because it means you don't have to do a custom redraw of that polygon shape every time you change it. If I wanted to make a slight adjustment here, so first of all, let's see it in action. Right? I'm going to hit play. Okay, it's a single unified collider. Now, what if I want to change the way this collider works? I can just move parts around. That's OK. OK, great. And then if I look at that, you can see the collider has immediately been redrawn. So I hit play now, and it still collides as a single piece, right? So this is very useful for those of you who are making these kind of games in 2D. It's a very common use case. OK, so if we look at the other example I've got here, it's an example where we are checking the edge radius. So if I hit play, you'll see each of these boxes has a very tight collision box, right, around it. We can actually look in the scene view, and we can take a look at that. Oops, I keep on clicking on the wrong thing here. OK, it's a very tight collider on each of these boxes. If I select that one, you can actually just about see it, right? The green outline on the inside. And that's what makes all of these boxes collide so closely together. But if I wanted to create the correct collision box, let's say for the box below, and I wanted those rounded corners, I would like to be able to push back the edge radius of the collider and create those rounded corners on the edges. So I'm going to do it by modifying these boxes. I'm going to modify them here. This is the new parameter that we added in Unity 5.6. It's the ability to change your edge radius. So let's see what that looks like. It's much easier to see it visually. So let's increase that. Right, so that pushes back the collision volume. So this can be very useful if you need a little bit more free space outside, or you're trying to simulate the shape like the one that we have at the bottom. OK, so there you go. Whee. Done. OK, so that's our edge radius. OK, so that brings us to the end of the 5.6 features. But I wanted to talk to you about stuff that is coming soon. And there's quite a lot of that. So let's start with a really important feature that a lot of you should be using, and that is the Sprite Atlas. How many of you in the crowd are doing some kind of atlasing for your games? Anyone using an atlas? Yep. OK. So 2D developers, they really care about their atlases, and they want them to work well. So in an upcoming version, we have the Sprite Atlas that replaces the current Sprite Packer with a faster, friendlier, and more versatile texture packing solution. And I'll show you two examples about how this works. But first, I want to talk about the advantages of the new packer, of the new Sprite Atlas, I mean. So first of all, it's easy to scale the workflows, right? With the new Sprite Atlas, you can pack individual sprites, one by one, or you can pack an entire multi-slice texture, or you can just pack a whole folder, right? I'll show you an example of that so you can see it. You also have more control. So when we were speaking to our users, we found out that what they really wanted to do was to access the Atlas itself. And they wanted to be able to set texture settings, for example, compression settings based on platform, right? Or maybe you want to change the filtering mode, right? So we're going to see examples of how all of that can be done. We're also going to show you how to directly get a sprite out of the texture atlas, out of the Sprite Atlas. And we're going to see an example of variants of the same atlas. So maybe you are making a high-definition version of your game for a strong device, for a very powerful device, and you also want to make a low-definition or a standard-definition version of your game for a lower-end device. Let's see a few of these features in action. OK, so for this, I'm going to be using the new 2017 beta. So let's take a look at Sprite Atlas. OK, so nothing's going to happen here. Nothing's going to happen in the scene view, because I'm just going to show you what it's like to work with the new Sprite Atlas. I'll zoom in a little bit, not too much. OK. So first of all, you create a sprite atlas the way you would create any other asset. So we just go to Create, Sprite Atlas. Okay. And there it is. So I'm going to call this one Atlas K1. Okay. And as you can see over here in the inspector, there are a few options. Among them, the ability to set some texture settings. So you can choose whether or not you're generating bitmaps, the filter mode, what the compression is like. And I'll talk about this one up here, the first one, which is the type. We'll talk about that shortly. I'll give you a quick hint. This is for doing master atlases and variant atlases. I'll come back to that. So what I want to do is I want to show you what it's like to work with packing in the new atlas. So I'm going to start with this one, and I'm going to make some copies. So we've got Atlas K1, K2, K3. And then I want to look at the sprites that we have. So we have all these sprites here with a bunch of different sushis, right? Different types of food. And I want to pack all of these. Okay, so I'm going to show you the different ways that we can do that. So I'm going to start with Atlas K1. And I am just going to drag a single piece of sushi in there. Okay, done. And I click on Pack Preview. And there we go. We've got a single piece, a single sprite that has been cut out from a texture that we imported that had a lot of different sprites on it. Okay, so that's the first example, very basic. Next step up, let's say we have this sprite and it has been sliced and we want to pack all the textures in there. I'm going to drag all of these in one by one, or I can just drag the whole texture in there. Okay, and I hit Pack Preview, and that's been repacked a little bit tighter. Okay, and again, this is an atlas, right? It's an atlas asset where you can set up all of these different options. But let's say that I'm really organized and I'm working with an artist and he's put all of our sprites neatly in a folder, and I can just pack them like that. Maybe I've got level 1, level 2, level 3, or I've got different themes, right, organized by folder. So let's look at Atlas K3. I'm just going to drag the entire sushi folder into that, all of that, one folder, Pack Preview, and I got everything. Okay? So this is it's a simpler workflow, and it makes things more modular, right? So you can work more easily with your atlases, because these are now simply assets. So that's an important point. Because they are assets, we can do the next part. Okay? And this is very interesting. We are going to make atlas variants. And we're also going to show you how to extract a sprite from an atlas. We're going to show you the API for that. And I'm also going to use asset bundles, because now that our sprite atlases are assets, we can use them very neatly in asset bundles. So let's look at all of that working together. So the next example is a little bit complicated, but it's not too bad. What we're going to do, the objective is to change this character into a lower res version. Okay? So let's look at what he's made of. So this is Potato Man, and he has some props, right? And he has a body. And on each of these, we have a script, right? Dress me up script. I'll show you what that does in a while. Now, each of the parts here come from a sprite atlas, okay? Each of these sprites. So what we want to do is, when we hit play, I want to load up an asset bundle that contains the standard definition version, the lower res version, and I want to replace all of his sprites with a lower resolution version. Okay? So let's take a look at the atlases first. So if we look at the sprites, here they are, right? And we have put all of these sprites into these atlases. So this is the potato atlas, right? Potato atlas. And you can see it's a normal master atlas. We're including it in the build. For the packing, we've set up a couple of options. But what's really interesting about this example is the standard definition variant. So for this one, I've made a variant. It's not a master, it's a variant. And when you make a variant, we want to set up a master atlas for it to be a variant of. In this case, that master atlas is potato. We've included it in the build, and we've scaled it down. So you can see the scale is 0.1, so this texture has become very pixelated. Again, why is it pixelated? Because we're using a point filter mode. So again, you have a lot of control over these textures and how they look. And then finally, if you look all the way at the bottom, we've added this to a asset bundle called Atlas SD. Okay, and we've done the same thing with props. Right, here is the high definition version of the props. Here's the standard definition version of the props. And then we've added that to Atlas SD. Okay. So now let's look at the script that's going to do all the magic. Here we go. It's dress me up async. And what we do is, here, we're going to get an asset bundle, and then we're going to load the asset, which is a sprite atlas, right? Here. And then what are we going to do? We're going to go through every transform, every child, and we're going to get the sprite that has the same name as the game object, right? As the child game object. So this is the nice new API. You can just grab a sprite out of an atlas and immediately use it. And then we're going to swap the sprite renderer's sprite with the one that we got from the asset bundle. Okay? Quite simple. So what does it do? Hit play. Boom. Right? So in this simple example, you can see how you can access different variants. The typical problem that you're trying to solve here is this is what you want to run on your low-end mobile devices. And then for your high-end ones, you grab a higher res asset bundle. And that's it. Okay, great. So the other important feature that's coming up soon is masking. So how many of you use some form of masking in your games? You want to put up your hands? Anyone use masking? Okay, great. So this is actually a very, very important technique that's been around for a long time. And it basically gives you the option to hide or reveal parts of a sprite or a group of sprites. And you do that based on another sprite that defines the mask. So this is a really simple example where we're trying to create cards. So if you're making a card game and you want to have a nice, interesting background inside your cards, and then you want things to move around, maybe you want to mask into another sprite or a group of sprites, and they're in different layers, you want it to look interesting. So you can use the sprite mask component to do that. Let's take a look at the sprite mask. So we're still in the new 2017 beta. Let's take a look at the sprite mask in action. So here we have these three characters, and they are going to be in this card together. And we want the card frame, everything that is outside of the card frame, we want that to disappear. We don't want to see that. Everything that is inside the card frame, we want to reveal. So if we look at the card frame, right? Look at this card frame. It's just a sprite renderer, but it has a child called card mask, and card mask has the new sprite mask component on it. Right? So this is the new sprite mask component. It's using a sprite called card mask, but why is this not working? Right? It's already been applied. We should be getting some kind of masking. Well, we need to define how the other sprites interact with this. So we're going to look at these three, and we're going to set it up so that they have a mask interaction. Right? We want them to be visible inside the mask. So I'm going to set that up here. I'm going to set it up for all three of these, all four of these, including the background. I'm just going to change this to 1, and now you can see they are inside. Now, if I were to move any of these objects around, for example, I go here, and I move this character around, you can see that only those parts of her inside this mask are visible, right? If you click on the sprite mask itself, you can see that there's a selection that shows you where that mask is. So even if I were to move the mask itself around, this effect can still work, right? So you can use this maybe in games where you've got a magnifying glass or you want to do a mini-map or something like this, right? This is a very common use case. Cool. Okay. Now, finally, I want to talk about, oh no, not finally yet. Second last. So tile map. Tile map is another feature that you'll be seeing very soon, coming out from the 2D team. Now, the tile map is a way for you to build tile-based games, right, on a grid. And we have just released a experimental preview release 4. So those of you who are playing with or creating 2D games and you want to try out the new tile map release, download it at this link, right? It comes with a demo game that we built especially for it. That also uses the custom brushes feature of tile map. So rather than me talking about it, maybe we could take a look at the tile map in action. Okay, so this is RoboDash, the example game that's released with experimental preview 4. Okay, so that was RoboDash. So if you saw all of the tools that were being used in that, as he was laying out the level, he was placing down different things. These are all parts of the brush system in the tile map, and you can extend that yourself to do interesting layout tools so that you can work between your programmers and your designers to create a custom set of brushes or tiles, especially for your games. And then finally, if those of you who were here just now for Arturo's talk on the future of animation in Unity, I just briefly want to mention that we are working on a solution to bring these native skeletal animation workflows straight into Unity. So those of you who are working on games that require skeletal animation, this is going to be something that you'll see in the future. We've begun development on it, but it's early days yet. But I asked the development team if I could showcase this at Unite Korea, and they were like, yes, they wanted to make sure. So if you were in Arturo's talk earlier, you've already seen this, but I'm just going to show you again. It's basically our rigging solution, our skeletal animation solution that brings 2D skeletal animation workflows. Okay, and this is a really early prototype. Okay, so we'll be really excited to see what you guys do with that stuff when it's released. So that's really the end of the previews of all the features that I wanted to share with you. But it's really important to me that I get to know what you are doing and that I hear back from you. So I just wanted to make a special point of emphasizing that we really need to hear from you. So please keep telling us what's working with our tools and what isn't. We are building these tools for you. And we want to make sure that you have a good experience using them, that they are useful to your studios, to your workflows, that they bring value to your companies and to your teams. So don't keep quiet if it's not working. Don't keep quiet if we're missing something. Let us know. Visit the forums, right? Let us know what you like, what you don't like. We will be there as well, talking about our new tools and making sure that you know how to use them. And keep trying the experimental builds. But please remember they are experimental. So if you use them in production, you may run into problems. But we also want to make sure that you are aware of what we are working on and that you get to try them so that the feedback we get from you is as good as possible. And of course, keep making awesome 2D games in Unity. So thank you very much. It's been a pleasure. I hope you had a great conference. And kamsahamnida.